I don't know how to say hi in Hungarian, but I can say unikum, balinko, and szólás nézet. Yeah. Yeah. Before I talk about making live data music, I first should maybe talk about making data music, because some people haven't done that before in R. And then I'll show you this live data music thing, the things I've been toying with lately. And then I will comment on the broader applicability of data music. This is how I think about data analysis in general. We have abstract data with no fundamental representation in the world. And the goal of data analysis is to get the data into our brains. But these data don't exist in the real world, so we have to convert it into forms that we can perceive, like scatter plots and data tables. These are both visual, but there's no reason it has to be visual. Maybe we could make kebabs, and we could eat the kebabs, and the taste and the smell and texture of the kebabs would tell us something about the data. But for now, let's start with just audio. I want to give you how am I going to do this? A sense of what I'm talking about. That was a bad idea. I should have, yeah. Okay, this is the iris data set. Every time I clap my hands, it's a new iris. And then the speed is the sepal length, so it gets faster when there's longer sepals. The pickup note, it's all in the legend there. So let's go, they're ordered by pedal length. So now once we get to a longer pedal length, well now, so different species have different pedal lengths. Yeah, so you can watch the whole thing later. So that's what I'm talking about. Yeah, okay. But now how do we make this in R? Well, first, this section is going to be just in general how we make digital music. First, think of sound as a series of air pressures. The air changes pressure and it goes into our ear and it hits the eardrum, and that's how we recognize the sound. So in R, we need to generate the different air pressures. Well, we do this with the assistance of a speaker. We send numbers to the speaker, and we can define it to be when the speaker is all the way out this way, that means -1, and when it's all the way this way, it means +1. Or the other way around, when we send +1, we get this. So in R, we have to construct a series, a numeric vector of range between -1 and 1. For example, you can use different numbers. Often you might, so here I'm not going to do the vector itself, but I'll plot the curve of this sine wave. And so this sine wave, it means that, can I do a pointer with this? I'm not going to try. Yeah, so there, it's the speaker's in the middle, and then there it's all the way at one side, and here it's all the way at the other side. This is a very low frequency wave. If we wanted to be able to hear it, it would have to be much higher frequency. But that's how we're generating the sound. This form of representing sound is called pulse code modulation, in case you cared. And yeah, so that's how once we have the frequency, we can generate the pulse code modulation form, and then we can send it to the speaker. But how do we get the frequency? Well, maybe you've seen a piano before. You have notes like this. You can convert these notes into frequencies. First, you number the notes. Each note of the piano gets a different number, increasing by 1 with each note. The black and white are the same. And then you use this formula that is about to show up maybe. Yeah, so, well, I can explain it, but I don't really care. Yeah, so it's that formula, and you can specify the basic coordinate system, sort of. So I have this thing that gives, the main one that's interesting is 7. That's the note. 440 is the base frequency, and 1 is the note that corresponds to the base frequency. So here I can say this is a major scale, and I can say I'm going to pick things out of the major scale based on chick weights, and then I'm going to use that as a note, and I'm going to pass it here, and I'm going to get these frequencies. And then with the frequencies, I'll generate that sine, and then I'll have, that I can play with my speaker. But there's more than just notes, because we have other things in music. We have rhythm and pitch and tempo. So I won't really explain this, but you can do all that too. You just have to make that into an R function. So here I say, at the top I have that frequency thing, then I'm going to have this thing to have two different instruments, a silence and a press of something, and this is just the amplitude of the wave, not the frequency. And then I chose this random rhythm over here, and that gives me the rhythm, and then I choose my frequencies. This forms a major chord, and then this is just the sine plot that I showed you earlier. And I put it all together, and I get this thing. Ooh. Oh well, you can listen to it later. Oh. Oh, cool. Yeah, that's good. Yeah. Oh, it's so slow. Yeah. Oh well. Yeah, you can look through the code and see what that means later. But that was all just generated from that code. Yeah. So that's data music in general. But now, the way I've been doing it, I didn't actually show you how I turn the numeric vector into a file. I'll show you that shortly. The issue is I'm generating a song that's maybe 3 minutes long, and I don't have a good way of, if I want to just play like 5 seconds of it to test something out, how to do it. Or in R, we make plots, and then the plot stays up there, and you can keep doing stuff in R while the plot's up there. But I don't have a good system for doing that with live music, and also, last thing is, it would be cool if I could do a live performance. And you'll see why that doesn't work presently with R. So the normal way of playing music out of a program, as far as I know, would be to send PCM audio to the sound server for your operating system. So some of these, SNDIO is OpenBSD, OSS, and also the Linux Pulse Audio and Jacker and a lot of systems. You can also send it directly to the sound card, but these make some of that easier because different sound cards support have different. Well, I don't need to come back here. Yeah, right. So the workflow here is you have your spreadsheet, you put it into R, you generate the PCM, and then you send that to. You call some C function that sends it to the sound server, and then that goes into the audio hardware. But the problem here is, The problem here is R does not have good concurrency. So when I do this, I wrote an OSS driver for R, so I can play sound out of R directly. I mean, I knew this was going to happen, but I just had to write it so I could say I did it. So you make your sound, you send it to the server, and then you have to wait for it to finish because you can't have a separate thread. So then I play the first sound, then I can do something else, then I can play the second sound. I can't keep playing the second sound while I'm doing something else in R. If I had a better concurrency support, I would do something like this. I would have my main thread, and then I would start this first sound playing, and while it's playing, I would keep filling around in, well, I don't actually use dplyr, so like R, and then I would play the second sound and keep doing something. Just like how you can plot something, and you can keep fiddling around in R, and then you can make your next plot. So that's what I would really like to be able to do. So maybe another way I can do this is I can, instead of doing it all within R, I could have a separate program that's a separate process entirely, probably, written in a different language, probably, that just waits for R to send it information. This is something, I did make a test of this, like, I did come up with something like this using web audio, although that wasn't a great idea. So I think this is the way to go, but my current implementation of it isn't good. But another approach that's similar is instead of sending the PCM information, so that vector of speaker positions, we could send some other high-level commands. So you can use a MIDI, you can send MIDI commands, which are simple things like, or they're very high-level things like play this particular pitch at this particular, for this time and with some other parameters. And then you can use a MIDI synthesizer for that. You can use, like, Superplot is a language that people use a lot for making music. AudioLyzar is an R package that sends high-level commands to another program that, it's the same idea as the others, except it's already supporting R. And JavaScript, I like this one. The idea is we send data to the web browser, but instead of sending PCM like I mentioned earlier, we send like, I want this tempo and this key, and then it'll change the note. And I think JavaScript is cool because then we can have a shiny with music where you like drag the slider and the music changes. So started working on that, but I couldn't figure out how to use HTML widgets. I learned about these good HTML widgets tutorials this morning, so maybe I will fix that, or maybe someone else here is ambitious and wants to fix it for me. But for now, what everyone does, as far as I can tell, including me, is you just generate a file, and you play the file with some command line editor. So you make that numeric vector, and then you save it to a file, and you can call system to play with the command line player. Usually, everyone, as far as I can tell, everyone except me uses WAV files, and I used to use that. But I found I prefer to just send the raw PCM files because Tunar, which is the package that we use for making the WAV files, has the annoying dependency of GNU Fortran. But my implementation of raw PCM is very, very simple. It's this. And in fact, most of this is just guarding myself. The main thing here is to make raw PCM, you just say add double of your vector, and it has to be numbers between -1 and 1, and then that is sufficient that if you specify things appropriately, that'll play out of your speakers. So I do that, and then I can use this called FFmpeg to turn it into whatever audio format I want. You don't have to write all this down. You can see it on my website. Yeah. So I think if we want better live audio for data music in R, the two directions I think we need to focus on are connecting to some standard operating system sound server in the first approach, as I said, which is we have some separate process that handles the concurrency for us. And the second thing is we need an HTML widgets that does the sound synthesis in JavaScript so we can combine it with our dashboards. Yeah, so this is the first one I said, and then, yeah, and the idea with Shiny is, well, yeah, you send these parameters. You don't send the raw PCM, but you send the parameters. Yeah, okay. And now that's all I have on that's all I've gotten on live data music in R. I'm going to keep working on it, but I'll comment now on the relevance of data music. Well, the first thing everyone always says is, well, maybe if you can't see, it'd be good to be able to listen to the data. Maybe I haven't looked at that at all, but that'd be good to look at. Another thing is. Maybe this is a good way of teaching an intuition about how data work and data collection, because a lot of people maybe aren't used to looking at plots, but used to listening to music, and somehow people seem to like it, I don't know. If you have a job, it's really good because it's helpful for pretending that you're doing something cool and useful. So, like, oh yeah. So Dijkstra said, we should never forget the crucial distinction between the salesman and the scientist. It is the salesman's duty to please his customers, or if that is too difficult, to fool them. And so here's a great example of that. Someone gave me this spreadsheet of data about activity of editors on online news publications. And it had these columns like activity generated per day and comments and this and that. I have no idea what this means, but it looks cool. And it sounds cool, right? So he can tell his customers that they're using this really cool data high-tech publishing program, and yeah, that's all that matters, because that's what data science is all about. If you're using data music, you can more easily convince your clients that you have some high-tech visionary product that they should buy. You can convince your workers that the data science methods are interesting enough to compensate for their terrible jobs and dismal career prospects, and you can maybe convince yourself that you're actually doing something worthwhile with your life. But the main thing I like about data music is the potential to expand, to do multivariate data analysis, as Tufte would say, as Edward Tufte would say, to escape Flatland. Let's not do that one. Yeah. So can we make that? That's a little better. Okay. Yeah. So maybe we have our data and we do visualization and we get it into our eyes. Our visual sense. This is called visualization. But you see, today we have big data. You got bigger. So now it doesn't fit in our eyes anymore. So maybe we need more senses. So music, that gets us a little bit further, or maybe we can even go further and use all the senses. So remember, I showed you this diagram. We can make scatter plots. We can make data tables, but can we make kebabs? Well, in fact, we can, and we can do it in ggplot. we use the geom_dir package, which I guess is going to take a little while to load. And I'll show you an example where I have my plot. This is the mileage data set from one of Hadley's packages. And here we're saying like the border, which is going to be like whether it's a kebab or a box with kebab contents in it. That's the whether it's 4-wheel drive or 2-wheel drive. Spicy is whether it's automatic or manual transmission. X and Y are the mileage, highway and city mileage. And then at the end, we're going to say we're going to do geom text and geom dinner. So we're going to get a scatter plot, except not a scatter plot, but labels for all the makes of car. And we're going to get orders of kebabs with the same labels. And then we can order the kebabs and put them on top of the scatter plot. And here we get all the dimensions from the scatter plot plus the dimensions from the kebab. So, for example, these two were spicy and this one wasn't. And this x-axis is highway mileage and this one's city mileage. So we learned that spicy, which was 4-wheel drive, I think? Yeah, no. It was automatic transmission, right? Yeah, automatic transmission meant lower mileage. And that's the main thing I want you to take away from this. When you... So data analysis is about, we have our abstract data that has no fundamental representation, and we have to find some representation so we can get it into our brains. And we have these typical visuals, but it's all about finding a metaphor that we can perceive. So understanding that, for example, when you're making a visual, that you need to use, if you're doing something based on the size of a circle, you need to scale it with the area rather than the radius, because that's how we perceive things. So data analysis, or well, visualization in music and food, it's all about finding the right metaphor to help people understand the data to get it into their brains. Thank you.
Thank you very much. Questions?
Yes. Find outliers in streaming data. So there's somebody following streaming data, and then he's falling asleep.
Yes.
An outlier, like there's me.
So the comment is that this is a great tool for finding outliers in streaming data. This is a thing that people suggest. You should make one. So actually one thing is visual. I think actually if you could only choose one sense, visual is a good one because it's very easy to limit what you're accessing. You can say like, I only want to look at this plot right now. I want to focus on this section of the plot I want to focus on. And also because there's no time dimension. But the other ones, like sound obviously has to be played over time. Touch and smell and taste, I think like the way you perceive things a few seconds later is very influenced by what you smelled, tasted right before because you get accustomed to it. Maybe, I'm not really sure. But I think there is something to this that the visual sense is like least tied to time compared to the others. Well.
Not a question, but a comment. We are sonifying real-time data from the LHC right now.
Cool.
There's a website you can go to during coffee break and you can listen to data that is being collected right now and being sonified.
So the comment is that they are sonifying data from LHC right now.
Yes.
And so now I'm wondering, the first one of these I made, I collaborated with someone who used to work at LHC, and he told me that, well, he told us that like right after we published that first one, it was about the financial crisis in the United States. Well, it was only using US data. He said right after that, he started seeing animations coming out of CERN. So I wonder if perhaps I influenced, or my collaborators influenced the creation of this sound animation. Yeah. I'll check it out. Yeah.
Can you combine the music and the kebab?
Sure, why not?
More
The
seriously,
kind of question is, can you combine the music and the kebab? Yeah, why not?
more seriously, it might be cool actually to combine the regular, visual display with the music. I don't know, just to, exactly as you say, just to escape, the flatland and having more things at the same time.
Sorry, what's the question?
So can you combine like the regular visual displays with the music?
Oh, I did it. Didn't you see?
You kind of did it, but it was kind of awkward doing the visual. like a regular kind of visual display.
Oh, I guess you could, yeah. But it's more, I don't I guess maybe I wouldn't show you the one that's like the regular one because this is like more boring, and I'm going to show you the best.
Oh, okay.
But yeah, why not? Okay, a video is just a bunch of frames of image. So you plot the images however you want, and then on my website you can see the command for combining them. Yeah. Whoa, I think David was first.
So you showed at the start of it, you talked about pitch and rhythm and taking those individual parts. I didn't spot if you were actually looking at different chord structures and keys, so you're looking at minor and major harmonics and things like that.
Yeah.
And I thought that when you were talking about applications, if you can combine that with sentiment analysis, you can literally create an emotional response to music based on the data.
Okay. So I'll address the second one first because that doesn't require referring to something. Sorry, the two comments questions were, first was about using different chords or different scales and major and minor scales and stuff like that. Yeah, that's enough? Okay, I don't know. And the second was you could combine, use some sentiment something, and then you could make music that sounds like happy or sad based on the sentiment. Yeah. So I think one of the things about data analysis, when we represent things as data and then we use standard plots, I think the cool thing is actually that we don't need to do that. That you can use a happy song to represent how sad something is. The whole point is that we're abstracting the real world so we can use these generalized analytical tools. So you could do that. Like, it may be easier for some people to understand, but the beauty of data analysis is that we don't need to do that. That you could make a song sound happier when what's something that wouldn't, I don't know, what's something that's like totally neutral, like the what?
Cars data set's pretty neutral.
Cards?
Yeah,
Cars? Okay, fine. Oh no, like, if I say that like, there are more trucks on the road versus more cars, that's like a value judgment, you know. But happier, and that's like, maybe that's a bad one, you know. Maybe that is dangerous. Okay, so like, let's say you're saying, wow, actually, maybe this is hard.
Guys, I suggest
Okay.
that in the break, but
Okay.
there are two other questions, Jeroen and someone in the back.
Okay, I'll answer your other one in the break too, I guess. Yeah, Dylan?
I was just wondering, seriously, the reason why visualization is so cool is because we can brain optimize for recognizing patterns in data, right? Visually. And our brains are also optimized for recognizing patterns in sound, but those are the words in the language that we go through. So I was just wondering if you were aware of this research where we actually try to really play data in a way that is ready to observers that are still very receptive to hearing particular patterns of data as their words and language for blind people. There's research where you can they can start hearing these patterns of data that we might even be able to see.
Okay, so let me see if I can summarize that. You think visual is very intuitive sense. Maybe we can also perceive sound, but you're wondering if there's research as to whether, like, kids who haven't learned how to, I don't know, had special training in analyzing this stuff can perceive patterns in the sound. Is that? Oh no, I'm not quite getting it. Okay. I'm like, there's time pressure, so I just want to say something. Yeah. But so first thing is, I think probably visual sense. Like, there's a good reason why we start with visual sense. Like, probably it is actually easier. I think also training is involved in learning to read graphs. So it's reasonable that training would be involved in learning to read data or listen to data music. And lastly, I actually have no idea whether this is a good idea. It just like seems like something worth looking further into.
Dinesh.
Maybe this will be not a question, but a suggestion. Have you ever thought about putting an extra step into the generalization of data science and connection between brains? Because here you put a human brain actually perception in psychological terms is pretty much about pattern recognition. But the humans are really more focused, more oriented towards visual pattern recognition. But for example, animals,
Wow.
that could be more. For example, dogs could be used for maths definition of snares and data. You get data, put
Oh,
them
that's
on,
great.
produce some snares, and observe the behavior or the change of the behavior of dogs. You
Okay.
also use other animals who are better at acoustic perception, play some music, for example songbirds, and then observe the behavior, the change of behavior of the animal.
Okay, yeah. So I will repeat the comment for the live stream. So apparently, Dennis knows better than I do that humans are very tuned to visual sense, but other animals are better tuned to other senses. So we could represent, the humans can make the data and then have the other animals analyze it for us. And then we can look at how they react. And that's how we'll understand our data.
Right, let's thank Thomas again.